Here we see a function that is already a bit optimized, so we are using previously calculated values, so it's more similar to what we have here in this formula here that it uses. We have a sum, we have a denominator, we have this power, but we have always the previous pre-calculated values. And here in this part here we take advantage of this, and also we can see, as I mentioned before, how factorials can grow very high values. So this, now I'm using 11 factors for both functions. So this is the previous function we've seen that uses the factorials, and this function now is this one that uses this recursive relation between previously calculated denominators, and we see the factorial here is very huge. This would not fit into a 16-bit integers, but with this optimized function we have here, it's not so huge values. Also, we can see now, if we, for example, we would just remove this print here, we don't need this anymore. If we use few number of coefficients, so now I'm trying to generate just one cycle of the sine wave of 500 Hertz, but I'm using 5 coefficients, and then we have, it starts like a sine wave, but then it explodes. If we increase, it starts to get closer, but then it explodes down. With 7 coefficients, we already have a full cycle of the sine wave, and we get better and better. The more we add coefficients, the better it gets here. So next, what we'll do, we will optimize even more, because we will not generate the full cycle. What we will do, we will just generate half cycle, and then we will use the symmetry between this positive part and the negative part. So this is what we are doing here. So now I will, if I would calculate 4 times the cycle length using the normal formula, I'll put here 4 times, and I would use, for example, 5 coefficients. We see that it just explodes, so we don't get any good results. But now with this optimization, every time it gets to, we will only generate half of the cycle, so just the positive and the negative, we are toggling the sign. So we are only using now 5 coefficients, and we see that we have our sine wave, and we can go indefinitely like this, because we are just generating half of the sine wave cycle, and we are repeating it. So we can generate as many seconds of a sine wave we want using fewer coefficients. So it's much faster, demands much less computational power.